Hi, so today I'll be going over quickly what our team did for the M3 challenge for 2026, also known as Moody's Math Modeling Challenge. So, the topic this year was the rise of gambling. What's at stake? So here's our executive summary. So basically, the executive summary is how in the US and the UK there has been an increasing rise due to online gambling sites and phone apps. Because historically there have been a lot of restrictions and bans on these sports gambling websites, but they have been becoming increasingly lenient, and a lot of people have been taking advantage of it over time. So here's our table of contents. There were 3 different questions. I'll get into them later on in the video. So question 1 was playing with house money. Question 2, knowing the spread. Question 3 was don't break the bank. Conclusion, references, and our appendix. So question number 1, playing with their house money. So the first problem basically asks us to find an estimate of a person's disposable income based on a lot of different factors. So here are our different assumptions that are just kind of like there in order to kind of do our model. So you can read through those. So here's our model development, model execution, and here's our actual model. The first 3 here are just defining some parameters like country, age, filing status, and salary. And this is the 12-part piecewise function that we came up with. So we split it up into 7 parts for US, as there were 7 age brackets, and 5 for the UK. So it would take that their average salary according to a data, minus their federal taxes, minus their FICA taxes, or social security taxes. And then I would take it from the original actual reported salary and find their average, about like approximated predicted disposable income. And this is the function to get that. These are different variables. You can just read through them with the symbol that we used, the variable name, and the units. And then here's our results using a lot of 12 different random sample scenarios with different demographics to predict the set disposable income. We used 1 per the part of the piecewise function. And our discussion kind of talks about that. And our sensitivity analysis was kind of like in order to test our model. So our sensitivity analysis were actually stated here, with our sensitivity value being higher than average. So our sensitivity analysis was basically calculated from dividing the percent change in gross income by the percent change in disposable income for a baseline individual. So basically, we repeated the gross income statements for different sample scenarios, and this kind of helps test the robustness of this model. We will eventually do this again later. We explained our strengths and weaknesses, and then we move on to the second question. This one was the hefty one. Question 2 was to calculate how much money does one person lose from sports betting throughout the entirety of a year. So these were the different characteristics and the demographics that we based our results on. So first, of course, here's our assumptions. The key assumption to note here is that gambling is assumed to be random, because the model that we used was a Monte Carlo simulation framework. If you don't know what a Monte Carlo simulation is, it's basically taking random samples over and over to solve problems that might be deterministic in principle. So we calculated the average hold for low risk and high risk. And we also split the demographics based on male, female, high risk, low risk, and the risk that the bet is actually holding. So step 1, we obviously calculated the stakes using the data given. Step 2, we've basically found the average monthly stake across all sports, right? So with that data given, we found the proportion, basically given in this here. The odds, the hold, the stake sigma, the average stake, the base bets, based on their gender and risk. So these 2 characteristics here will come into play later when we actually go into our model. So the weighted standard deviation, that one's pretty simple, converting to log normal sigma, average across all sports, and our model execution. This is where our models actually come into play. So I split the Monte Carlo simulation into 4 different models. The first model being a low risk male, second being high risk male, third being low risk female, and fourth being high risk female. So this each gave and I split each 4 of these also into 4 different age groups, which gave them their mean average annual loss based on their risk and demographics. And these are our discussion and our results. And eventually we averaged out all of those with a weighted average to conclude that on average, Of the bettors in the entire world, or in the US and the UK, the average loss per bettor per year is about $950. And then we move on to question 3. Question 3 was a lot of like, so what? Because we lose $950 annually through gambling, how does this $950 affect a lot of other things? Because obviously $950 is a lot of money, but with the time value of money, this can be a lot more. So what we decided to do here was take two assumptions here, that they work 40 hours a week and 2,080 hours a year. This is just the average work year. And a person who does not gamble will save the $950 per year, and they can invest that money. So our model is basically investing using the S&P 500 average returns. Basically, we calculated how much labor hours were lost in order to cover that $950. So our investment growth, we took a lot of different types of investment ideas, and we showed that you essentially lose a lot of time and money just by sports gambling on average. And here's our key takeaways and our final conclusion. So our final conclusion just kind of concluded all of those. I'll quickly talk about what the challenge actually was. Maybe I should have done this in the beginning. But basically the challenge, you get 14 hours of straight work. If you start the timer, you have 14 hours to create a research paper like this with a team of 4 other students at your school to answer 3 different questions on a different topic every single year with a model. So if you have any questions, you can always let me know or comment down. I'll quickly show you guys our references. These are our references. This was the data set that they gave us, and these other 20 links were just the links that we looked online for. So our appendix also included the code that we used. The first part was for the first model, where we calculated the disposable income. The second part was the Monte Carlo simulation, where this is for the 4 different types of risk and gender combinations. So we have men low risk, women low risk, I skipped over men high risk, and we also have women high risk. So that was our M3 challenge. I did this challenge with Pranav Vedula, Jumadiao, Charlie Kertgate, and Nolan Boligitz. So hopefully the results will come out in like a week. Maybe I'll put them in the comments if we do win anything. But yeah, that was our M3 challenge for this year. Thank you guys for watching.